Good day, viewers. We are to determine the nth term of this given sequence 4, 15, 32, 55, and 84. Now, first of all, we are not told whether it is arithmetic or geometric sequence. So, to know whether it is arithmetic, we will subtract the terms and see whether we'll get the same difference. 15 minus 14 is 11. 32 minus 15 is 17. That means they don't have the same common difference. Now let's check whether it is geometric progression. 15 minus 4 and 15 divided by 4 is going to be 3 whole number 3 over 4. 32 divided by 15 will be 2 whole number 2 over 15. So that means they don't have the same common ratio either. So since they don't have the same difference and they don't have the same ratio, that means they are not arithmetic progression and it's also not geometric progression. So now let's get the difference between the values first. 15 minus 4 is 11. 32 minus 15, 17. 55 minus 32 is 23. Then 84 minus 55, that gives us 29. If you look at this now, the differences between the terms are not the same. But there is something common to the differences. The difference of the differences are equal. That is, 17 minus 11 is 6. 23 minus 17 is 6. 29 minus 23 is 6. So, the difference between them is 6. So, having gotten the 6, you will now say 6 divided by 2. That gives you 3. This type of sequence in which the difference of their differences are the same, we call it quadratic sequence. So when you get the second differences like this, you divide the 6 by 2. That gives you 3. So that 3 will now give us the first term, which is 3n squared. We will keep that one aside. Now, after getting 3n squared, we will now use that 3n squared to derive, this is 1, 2, 3, 4, 5. We will use this 3n squared to derive another 5 terms. When n is 1, 1 squared is 1, multiplied by 3, that's 3. When n is 2, 2 squared is 4, multiplied by 3, 12. When n is 3, 3 squared is 9, multiplied by 3, we have 27. When n is 4, 4 squared is 16, multiplied by 3, we have 48. And then lastly, when n is 5, 5 squared is 25, multiplied by 3, that is 75. So these are the first 5 terms using this formula. And then we have another 5 terms from the original question. So we are going to write each of these values under these terms. This is 3, and this is 12, this is 27, the next one is 48, and then this is 75. So now, we will find the difference between them. That's, we subtract. 4 minus 3 is 1. 15 minus 12, that is 3. 32 minus 27, that gives us 5. 55 minus 48 is 7. 84 minus 75 is 9. So this new sequence that we have derived, if you look at them, they have the same difference, like common difference. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So we can call this one an arithmetic sequence. And then the formula for nth term of a sequence is a plus n minus 1d. So in this place now, our a is the first term, which is 1. The n, we don't know. Then the common difference, 3 minus 1 is 2. That will be 1 plus, if you open this bracket, 2 plus n, 2n. 2 times 1, 2. So we have 2n. 1 minus 2 is minus 1. So we've gotten 3n squared initially. And now we've gotten 2n minus 1 for this arithmetic part of the sequence. So now the nth term for the question initially will now be 3n squared, then plus 2n minus 1. So 3n squared plus 2n minus 1 is the nth term for this given sequence. So to confirm if all you have done is correct, this is the first term, that is n equals 1. If you slot in that 1 here, we are supposed to have 4. 1 squared is 1 times 3, 3. 2 times 1, 2. 3 plus 2, 5 minus 1, that is 4. And if you also put second term, which is n equals to 2, 2 squared is 4. 4 times 3, that is 12. 2 times 2, that is 4 minus 1. 12 plus 4, 16 minus 1, that is 15. So this formula has been confirmed to be the nth term for this sequence. Thank you.